What caused the unexpected floods in Dubai, a city known for its arid climate? This question has been on the minds of many, following the recent extreme weather events in the typically dry and sunny city. It's an anomaly that's left scientists, climate enthusiasts, and the general public alike scratching their heads in wonder. In the midst of this mystery, two key factors have surfaced as potential culprits: El Niño and warmer sea surface temperatures. For those unfamiliar, El Niño is a natural climate pattern where warm waters rise to the surface of parts of the Pacific Ocean, influencing weather systems around the globe. On the other hand, warmer sea surface temperatures are often a result of human-induced climate change, adding more moisture to the atmosphere and making heavy rainfall more likely. These two factors, working in tandem, have been identified as major contributors to the unexpected floods in Dubai. But you may be wondering, so how exactly did these two factors lead to the floods in Dubai? Stay with me to find out. Firstly, we need to understand what El Niño is and how it impacts global weather patterns. El Niño, Spanish for the child, is a climate pattern that occurs when warm waters rise to the surface of parts of the Pacific Ocean. This typically happens every 2 to 7 years and can last for up to a year or so. But what causes El Niño? It's a dance between the ocean and the atmosphere. Normally, trade winds blow across the Pacific, pushing warm water towards the western Pacific and allowing cooler water to rise up on the eastern side. But every now and then, these winds weaken. When this happens, the warm water doesn't get pushed as far west as usual, and instead it spreads further east across the Pacific. This is the start of El Niño. These shifts in ocean temperatures aren't just confined to the Pacific. They affect weather patterns around the globe. In some areas, like the western Pacific, it can lead to droughts. In other regions, such as the eastern Pacific and the southern part of the United States, it can result in increased rainfall. You see, warmer ocean surfaces add more moisture to the atmosphere, and when there's more moisture in the air, it can lead to heavier rainfalls. So, regions that are already prone to rain can experience even heavier downpours, while areas that are typically dry may suddenly find themselves dealing with unexpected precipitation. But El Niño doesn't work alone. It's part of a trio of climate patterns, along with La Niña and the Southern Oscillation. Together they're known as ENSO, or the El Niño Southern Oscillation. And while El Niño is the warm phase of this cycle, La Niña is the cool phase, characterized by cooler than average ocean temperatures in the equatorial Pacific. Now that we understand El Niño, how does it connect to the floods in Dubai? Secondly, the role of warmer sea surface temperatures in this scenario cannot be overlooked. It's like a pot of water on a stove. The hotter it gets, the more it bubbles and steams. This is similar to what happens when the sea's surface temperature rises. The warmer the surface of the ocean becomes, the more water evaporates into the atmosphere. This evaporation is not just any water, it's actually moisture-laden air. Picture it this way: the warmer the ocean, the more water it sends up into the sky in the form of steam. This steam, or moisture, is stored in the atmosphere, creating a kind of invisible reservoir above our heads. But here's the catch: the atmosphere can only hold so much moisture before it becomes saturated. Once it reaches this saturation point, the excess water has to go somewhere. And where does it go? It falls back down to Earth in the form of precipitation. In most cases, this precipitation is a good thing. It waters our crops, fills our rivers and lakes, and provides the fresh water we need to survive. But when there's too much moisture in the atmosphere, it can lead to heavy rainfall. And when this rainfall is intense and sustained, it can result in floods. This is why warmer sea surface temperatures are a key player in the occurrence of heavy rainfall. The higher the temperature of the ocean surface, the more moisture is sent into the atmosphere, and the greater the likelihood of heavy rainfall. It's a domino effect that starts with a single rise in temperature and ends with a deluge of rain. With this in mind, let's delve into how these two factors combined to cause the floods in Dubai. So, how did El Niño and warmer sea surface temperatures lead to the floods in Dubai? Well, the first piece of the puzzle lies in the fact that El Niño, which we discussed earlier, can significantly heat up parts of the Pacific Ocean. This warming trend doesn't stay isolated to the Pacific. It generates a chain of atmospheric events that affect weather patterns globally. When the sea surface temperatures rise above the average, it has a profound impact on the amount of moisture in the atmosphere. Think of the ocean as a giant kettle. As it heats up, it starts to boil off more water vapor into the air. This additional moisture is transported around the globe by wind patterns, often ending up in regions that wouldn't typically see such high levels of precipitation. Now let's bring Dubai into the picture. Dubai, like many parts of the Middle East, is typically arid with very low annual rainfall, but in the context of an El Niño year, things can change dramatically. The increase in atmospheric moisture, combined with specific wind patterns, can lead to unusually high levels of rainfall in areas that are usually dry. This is precisely what happened in Dubai. With the El Niño effect in play and the sea surface temperatures higher than average, the city found itself in the path of unusually moisture-rich air currents. The result? Record-setting rainfall. But Dubai's infrastructure, like many arid regions, isn't designed to handle such high levels of rainfall. The city's drainage systems were overwhelmed, leading to widespread flooding. It was a stark reminder that even regions typically associated with heat and dryness are not immune to the effects of global climate phenomena. The floods in Dubai, and indeed in other parts of the world, underline the interconnectedness of our global climate system. What happens in the Pacific Ocean doesn't stay in the Pacific Ocean. The impacts ripple out, affecting weather patterns and climatic conditions across the globe. And it's not just about El Niño. The underlying trend of rising ocean temperatures due to human-induced climate change is adding fuel to the fire. As the oceans continue to warm, scientists anticipate that extreme weather events, including heavy rains and flooding, will become more common, even in places where they were once rare. Now that we've covered the causes, let's summarize our key points. Let's take a moment to recap what we've learned about the causes of the Dubai floods. We started off by understanding El Niño, a climate pattern that occurs when warm waters rise to the surface of parts of the Pacific Ocean. This phenomenon is not just a simple oceanic event, but a vast climatic occurrence, influencing weather patterns across the globe. We then discussed the role of warmer sea surface temperatures. These higher ocean temperatures add more moisture to the atmosphere, which in turn makes heavy rainfall more likely. This is because warmer water evaporates more easily, and this extra water vapor can form clouds that lead to intense rainfall. Now, let's connect these dots to the floods in Dubai. The city experienced record-setting rainfall, causing damaging floods and fatalities. This came as a shock to many since Dubai is generally known for its arid climate and rarely experiences such extreme weather events. This unusual phenomenon was due to the combination of El Niño and the warmer sea surface temperatures. The higher ocean temperatures added more moisture to the atmosphere, making this heavy rainfall more likely. But let's not forget the bigger picture here. These extreme weather events, from floods in Dubai to other parts of the world, are not isolated incidents. They are part of a larger global climate dynamic exacerbated by human-caused climate impacts. We're seeing more frequent and severe weather disasters, and understanding these patterns is crucial in mitigating the effects and adapting to our changing world. So there you have it. The unexpected floods in Dubai were a result of a combination of the El Niño phenomenon and warmer sea surface temperatures. Thank you for joining us in this exploration of global climate dynamics. Stay tuned for more insightful discussions on climate phenomena and their impacts around the world.